We've already learned how to solve a system of equations by graphing, finding out where those two lines intersect. Today we are going to learn how to solve that same sort of system algebraically using a method called substitution. Write down this system of equations and we'll solve it together. X minus 4y equals 11. 4x minus 2y equals 2. The first step is to pick an equation and solve it for either x or y. In this case, I recommend solving for x. The reason being, x doesn't have a coefficient in this first equation. When you are solving for a variable and have to divide out a coefficient, it can get messy with a lot of fractions, and if you can avoid that, it avoids getting confused. So I suggest if you have an x or a y that doesn't have a coefficient, choose that one to solve for. In this case, x in the first equation. And to solve for x, we're just going to add 4y to both sides, to isolate it on one side of the equal sign. And we arrive at x equals 11 plus 4y. Once we know that x equals 11 plus 4y, we can simply take it and substitute it in for the x in the second equation. Instead of writing x, I'll simply write 11 plus 4y. We can do this because if x equals 11 plus 4y, we can write 11 plus 4y anywhere that we would normally write x, since they're equal values. My resulting equation is 4 times the quantity 11 plus 4y minus 2y equals 2. Now we have a regular equation that we're used to solving, and we have one variable to solve for, that y. My first step is going to be to distribute this 4, and we're going to distribute it to the 11, and we're going to distribute it to the 4y. So 4 times 11 is 44. 4 times 4 is 4 times 4y is 16y. And then we simply rewrite minus 2y equals 2. Now I see some like terms on one side of an equal sign that could be combined or collected. We'll combine or collect 16y and minus 2y, and that results in 44 plus 14y equals 2. Finally, we can subtract away that 44, resulting in 14y equals negative 42. And then divide away the 14. Now we know that y equals negative 3. If you recall from solving systems by graphing, the answer will always be an ordered pair. We will always find an x and a y. So far in this problem, you've found your y. Y equals negative 3. So we have found exactly half of the ordered pair we need. We now need to go back and find x. Since we know that y equals negative 3, again we can just simply substitute it negative 3 in anywhere we have a y. So I'm going to take this first equation. You could use either one. I'm going to take the first equation, and instead of y, I'm going to write negative 3. That leaves me with x minus 4y times negative 3 equals 11. And then just solve for x. So let's multiply this negative 4 times this negative 3. That equals 12. Then let's subtract that 12 away from that x. And that leaves us with x equals negative 1. Now that we know that x equals negative 1 and that y equals negative 3, we have our ordered pair. Let's try another one. Following the steps that we just learned, go ahead and write down this system. Negative x, negative y, or negative x minus y equals 2. And x plus 2y equals negative 6. You give it a try. Follow the steps we just listed and see if you can't find your ordered pair. Pause the video, and then when you've finished, resume the video to check your answer.